Welcome to your Algebra 2 Lesson 5.4. Today you're going to factor and solve polynomial equations. So the objective is that you will factor and solve polynomial equations. Now when you factor, the very first thing you do always is look for a greatest common factor. In other words, like it says at the top here, you find a common monomial factor, and then once you've done that, you look to see if you can factor any further. Okay, so we're going to factor the polynomial completely. So first thing we do is look for a greatest common factor. Let's see, we've got x cubed plus 2x squared minus 15x. All three terms have a factor of x, and so we're going to factor out the x. And so x cubed divided by x is going to be x squared. 2x squared divided by x is 2x. And then minus 15x divided by x gives us minus 15. So now we look at the x squared plus 2x minus 15, and you either use the AC method or trial and error, and you factor that to be x plus 5 times x minus 3, and we still have our factor of x out front. So let's just double check. 5 times negative 3 is negative 15. Checking the middle terms, 5x minus 3x gives us plus 2x, so we are good to go. And we are done. All right, our next one, we've got 2y to the 5th minus 18y cubed. So we can factor out the smaller power of y, so we're going to be able to factor out y cubed. And also both terms have an even coefficient, so we will be able to factor out a 2. So altogether, our greatest common factor is going to be 2y cubed. And so when we factor out 2y cubed from the 2y to the 5th, that's going to give us y squared. And then we'll have our minus 18y cubed. Let's say we factored out the 2, so that leaves us with a 9. And then we factored out the y cubed, so there's no powers of y remaining for our second term. So we've got 2y cubed times y squared minus 9. Now, if you look at that, y squared minus 9 is a difference of two squares. Difference of two squares can kind of be abbreviated as dots. You always want to look for dots. Greatest common factor, and then you look for dots. You look to see if you can factor a trinomial. You look to see if you've got a perfect square trinomial, which abbreviated is PST, so like psst, like a little secret. So you always look for that too. So we do greatest common factor, and then we look for dots. That's a little secret that we're going to look for perfect square trinomial, and then also for other trinomials we factor using the AC method or with guess and check. Okay, so y squared minus 9 is a difference of two squares. It's dots. And so 9 is 3 squared. So we're going to have 2y cubed times y plus 3 times y minus 3. All right, for part C, we've got 4z to the 4th minus 16z cubed plus 16z squared. So we're going to be able to factor out a 4, and we're going to be able to factor out z squared. So 4z squared will be our common monomial, our greatest common factor. And so then we're left with z squared minus 4z plus 4. All right, 4 is a perfect square. We've got a perfect square in the front with the z squared. 4 is 2 squared, so 2 times z times 2. Yep, this fits the perfect square trinomial pattern. And so we've got 4z times z minus 2 squared. All right, two new patterns for us. And so this is something that you're going to need to memorize. So you need to go ahead and memorize it now. We've got the sum and difference of two cubes. So there's a pattern for both sums and differences this time. So you can think of an abbreviation here, looking at the S and the O and the C for the sum, that's socks, and differences, we got docs. So we're going to do greatest common factor, and then we're going to go psst, perfect square trinomial to remind you of that. We're going to look for dots, socks, and docs. Okay. And then we look to see if we can do just kind of our typical trial and error AC method factoring of any trinomials. Okay, so on to memorizing these formulas. A cubed minus B cubed factors out to be A minus B times A squared plus AB plus B squared. Now, if we had a 2 right here as a coefficient of that middle term there, we would have a perfect square trinomial, but we don't. A squared plus AB plus B squared is always going to be prime. So you're never going to be able to take that any further. So let's look here. You've got a minus in the unfactored form, the A cubed minus B cubed form. All right, you start off with a minus in your little binomial factor. And then everything else is going to be plus. And it's going to be A squared, AB, B squared. Okay? For A cubed plus B cubed, you start off with a plus. You've got a matching of the signs in the binomial factor. So you've got A plus B, first base plus second base, and then you switch the sign. You always switch the sign here in the trinomial, so you're going to have A squared minus AB plus B squared, because you always end with something positive. Okay? So you match the sign, you do the opposite, end with something positive. Match the sign, do the opposite, end with something positive. Okay? It's like if you're out somewhere and you see someone cute and they give you a sign that they're interested, like they smile at you, you might smile right back at them. Okay, do the same thing. Or if they look at you and give you one of those nice looks, you look at them. You match the sign. You give them the same sign back, but then you look away. You do the opposite. But then, if everything's going well, you always end on something positive. This is cheesy, has nothing to do with math, but it has helped kids, ever since I thought of it, it's helped kids to remember how to do the signs here, because that's what trips people up. So, if they give you the plus sign, you match it, and then you do the opposite, and you end with something positive. They give you the minus sign, you match it, you do the opposite, you end with something positive. Okay? And then it's going to be just A by itself, B by itself, A squared, A times B, and then B squared. And that's the pattern on both of them as far as the terms themselves. So you got to memorize this, whether you remember my cheesy, they give you a sign, you match the sign, then you look away, you know, do the opposite, and then you end with something positive. If that helps you, great. If you're going, I have no idea why she's talking about that, just memorize the patterns. You got to know them. All right, we're going to factor the polynomial completely, and we've got x cubed plus 64. Okay, no greatest common factor. It's not a perfect square trinomial. It's not a trinomial at all. It's not a difference of two squares, so we start and we go, what else could it be? Oh, think of socks and docks, sums and differences of cubes. Okay, so 64 does equal 4 cubed, so it is a perfect cube. Okay, so we're going to do sum of two cubes. A cubed plus B cubed equals A plus B times A squared minus AB plus B squared. All right, so we've got x cubed plus 4 cubed. So that's going to factor out to be x plus 4 times x squared. Now do the opposite sign, so minus x times 4 plus 4 squared. So that's going to give us x plus 4 times x squared minus 4x plus 16. And we don't have to consider factoring anymore because this little trinomial here is always going to be prime. Okay, on this one we've got 16z to the 5th minus 250z squared. So first thing we do is factor out a common monomial, our greatest common factor. And so we're going to factor out 2z squared. So 16 divided by 2 is 8. We have z to the 5th. We factor out the z squared, so that gives us z cubed, and then minus 125. All right, so we've got a difference here. This is cubed. Let's think. 8 is 2 cubed. 125 is 5 cubed. So we've got a difference of 2 cubes. Okay, so remember the pattern here is a cubed minus b cubed times a minus b times a squared plus ab plus b squared. Okay, so before we actually factor, let's just double check that we know what our bases are. In other words, what our a is and what our b is. So we're going to write 8z cubed as 2z, the whole thing cubed, because 2 cubed is 8 and z cubed is z cubed. And then minus 125 is 5 cubed. Okay, so for the pattern's sake, our A is 2z, so everywhere we see A in the factored form, we're going to plug in 2z, and our B is 5. So everywhere we see B in our factored form, we're going to put in 5, and then we'll clean it up. So we keep our greatest common factor out here out front, so 2z squared. So we're going to have A minus B, so 2z minus 5, and then we've got our trinomial. It's A squared, so 2z squared plus, because we're going to use the opposite sign there, A times B, so 2z times 5, and then plus, because we always end on something positive, and then B squared, so 5 squared. We need to clean up this trinomial a little bit. We're not going to be able to factor it because it's always prime. But when we clean it up, we're going to have 4z squared plus 10z plus 25. And of course out front we bring on down the factors that we already had that didn't need to be cleaned up. So 2z squared times 2z minus 5 times 4z squared plus 10z plus 25. And we know we're done because this trinomial, when you do sum or difference of cubes, the trinomial that you get is always prime. Okay, so these two factoring patterns are two new patterns you need to remember. Okay, so if you need to make flashcards, make flashcards. If my little silly story about, you know, it's kind of like when you meet somebody and they give you a good sign, so you match it back and then maybe do the opposite and then end with something positive. If that helps you remember it, that's great. If it doesn't, again, don't worry about it. All right, let's look at one more example for this video, and then we'll stop and we'll do video 2 for lesson 5.4. We're going to factor by grouping. Well, y'all are great at this because we do it whenever we do the AC method. All right, you're going to factor the polynomial x cubed minus 3x squared minus 16x plus 48 completely. Now, honestly, you start off looking for a greatest common factor. And you get kind of excited thinking maybe there is one because you've got x cubed minus 3x squared minus 16x, but then you have that plus 48. So you're not going to be able to bring out any x's. Your leading term here, the x cubed, has an understood coefficient of 1, so you're not going to be able to bring out any number, numerical common factors. So what we're going to have to do is consider other factoring methods. So we consider our patterns, perfect square trinomial, dots, sots, and docs, and none of those work. It's not a trinomial. You've got 4 terms, so you're going to have to use grouping. And remember this, where you take the terms and do 2 at a time. Sometimes, there are occasions where we have to do 3 and then 1, but mostly what you will see are ones where it's just 2 and 2. So we're going to take the first 2 together and then the second 2 together and see if we can work with that. If not, we'll look at regrouping. All right, so we're going to consider the x cubed minus 3x squared. We're going to find a common factor just for those 2, and then the 16x and 48. Okay, so there we have it written down. We're going to factor by grouping. So looking at the first 2 terms, you've got x cubed minus 3x squared. Relative to just those 2, you can factor out an x squared, and so that's going to leave you with x minus 3. Now looking at the second 2, you've got minus 16x plus 48. Because there's a minus in front of this term right here, we're going to have to factor out minus something. So we're going to have to be real careful with our signs. Well, 48 is actually 16 times 3, so we can factor out a minus 16. So here's our minus 16. So let's see, negative 16x divided by negative 16 is x. 48 divided by negative 16 is negative 3. Okay, so at this point we have gone from 1, 2, 3, 4 separate terms to one big term to a second big term. So we've got 2 terms, and they actually have a common factor of x minus 3. So They call it using the distributive property. I call it, okay, you pull out the greatest common factor of x minus 3, and then whatever's left goes in a set of parentheses. Typically, I write the x minus 3 first, but I left it this way because I wanted you to know that it doesn't matter which order you write them in, but you've got to put what they have in common in a set of parentheses, and then whatever was left over goes in a set of parentheses. So we have our x minus 3 and our x squared minus 16. Now, we look to see if we can continue factoring. Okay, in particular, you're looking for a perfect square trinomial. A trinomial you can factor another way, dots, stocks, and socks. So difference of two squares, sum of cubes, difference of cubes. We've got a difference of two squares, so we're going to factor that to be x plus 4 times x minus 4, and then our x minus 3, and we are done. Everything, we've got all nice little binomial factors, so we are done factoring this polynomial. Okay, that's it for our first video. I will see you again in just